Let's do some more examples of using these various exponent rules, including negative exponents. And I'm just taking things from the even problem sets on page 91. Look at number 28. So number 28 would like us to simplify 5s to the negative 2, t to the fourth, to the negative 3. So just like every other problem, there are a number of approaches we could take. We could use the power of products rule. We could use a power of the power rule. We could use negative exponent rules. And all of those don't really matter what order you do them in. I think that what I'm going to do is to use the power of a power rule and get rid of this set of parentheses first. So because I've got 3 different bases inside the parentheses, that really means that this negative 3 is going to all of them. So I'm raising 5 to the negative 3, I'm raising s to the negative 2 to the negative 3, and I'm raising t to the fourth to the negative 3. And you probably knew about the s and the t, but you might have missed the 5. That's a very, very common error. So let's think about this. 5 to the negative 3, that's 1. S to the negative 2 to the negative 3. So if I'm raising a power to a power, the shortcut is to multiply. So that's going to be a negative 2 times a negative 3. And then t to the fourth, well, it looks like a 5, doesn't it? S. Let's make that an s. There we go, s. Oh, still looking like a 5. S. And they will make this one look more like a 5. There, that's a little better. And then finally, t to the fourth to the negative 3. So t to the 4 times negative 3. Now let's do the multiplying. So I've got 5 to the negative 3. Negative 2 times negative 3 is positive 6. So I've got s to the positive 6. And 4 times negative 3 is negative 12. So I have t to the negative 12. Now I'm going to deal with the negative exponent rules. So I've got 2 bases that have negative exponents, 5 to the negative 3 and t to the negative 12. And I'm going to move them over the fraction bar or write their reciprocal, however you want to think about it. The s to the 6 is going to stay right where it is. So this guy's going to stay. All right, so now s to the 6 is the only thing left on the top. In the bottom, I have 5 cubed and t to the 12th. Remember, when we move a monomial or move a base with its exponent, we change the sign of the exponent. So it goes from being negative to positive. Now I just have one more step to take, and that's to evaluate the 5 cubed. So 5 times 5 times 5 is 125. So my final answer here is s to the 6th over 125 t to the 12th. And there's my answer. Let's do another one. How about, let's do number 30. Number 30 looks like it might be pretty easy, so there's just x's and y's, but there are a lot of negatives there. So 30 has x to the negative 1, y squared over x squared, y to the negative 1. And I think I'm going to use quotient rules, and then if I have any negative exponents left, I'll use the negative exponent rule. I'll just be careful that I put the like bases together. So let's deal with the x's first. I am dividing, so I'm going to subtract the exponents, negative 1 minus 2. Then I'll deal with the y's, 2 minus a negative 1. So negative 1 minus 2 is negative 3. So now I've got x to the negative 3. And 2 minus a negative 1 is 2 plus 1, so I've got y cubed. 2 plus 1 is 3. Now I'll use negative exponent rules and move that x cubed into the denominator. I'll be left with y cubed on top and x cubed on the bottom.